Hi guys and welcome back to the ACE Academy. In this video, we'll be looking at sketching the hyperbolic function using a given equation, and then we will go on to obtaining an equation for the hyperbolic function given a sketched function. So in the first part of this video, we are going to sketch the function that is on the screen right now, and that is the function with the equation f of x is equal to 2 over x plus 2. Now, in order to sketch the hyperbolic function, we are going to look at its significant points or its significant characteristics. And when it comes to the hyperbolic function, it has two very significant characteristics, and that is its vertical and horizontal asymptote as well as its shape. So looking at this equation, we can see that it has a horizontal asymptote with the equation y is equal to positive 2, which means that if I estimate on this blank Cartesian plane where positive 2 is, I would say it is around here. I'm just estimating any point. It doesn't really matter. We will give it a value, right? We will label it. At that point, I will have a horizontal asymptote with the equation y is equal to 2. So let's draw that in. And this line would have the equation y is equal to, that line has now been labeled. Let's look at its vertical asymptote. And the vertical asymptote of this hyperbola would be x is equal to 0, because its vertical asymptote lies on the y-axis. Now that we have the asymptotes of this function, we are going to look at the shape of the function itself, and that can be given using the a value right here. So using the standard equation, which is f of x is equal to a over x plus q, we use the q value to obtain our horizontal asymptote, and now we are going to use the a value to obtain the shape. Now let's see if we remember this correctly. When a is positive, a is greater than 0, the function would lie in the first and the third quadrant. When a is less than 0 or negative, the function would lie in the second and the fourth quadrant. Now in this case, a is positive, it is positive 2, so we know that it is going to lie in the first and third quadrant. So we can simply draw in the shape of the function. And there you have it. That is how you plot a hyperbolic function using a given equation. Right, now what I want you guys to take note of is the new domain and the new range. Looking at the domain, that is all the x values for which the function exists. And in this case, this function will exist from negative infinity to positive infinity. It will only not exist at x is equal to 0, because that is our vertical asymptote. So we can say x is an element of R, x does not equal to 0. Let's look at the range for this function. We know that this function will exist for every single y value from negative infinity to positive infinity, except here at the horizontal asymptote with the equation y is equal to 2. So our domain would be y is an element of R, but y does not equal to 2. It's that simple, guys. Right, moving on. We are now going to find the equation of the given hyperbola, which is sketched on your screen right now. Let's look at the information that we have. We have its horizontal asymptote, which has the equation y is equal to negative 3, and we have a point on this function. We also know the shape of the function looking at the way it has been plotted. So let's go ahead and write the standard equation for this function. It is y is equal to 1 over x the standard equation would be y is equal to a over x plus q. We already know our q value, which is -3. So we can go ahead and substitute that in. That leaves us with one unknown that we need to define before we have completely obtained the equation for this function. So how would we solve for a? We know that a is going to be a negative number because a lies in the second and the fourth quadrant. Okay, so let's go ahead and substitute in the known point to obtain a. Substituting in that point that we have in the function, we would get -2 is equal to a over -7 minus 3. Now all we would have to do is manipulate this equation in order to make a the subject of the formula. So -2 plus 3 would end up being +1. +1 is equal to a over -7. Manipulating further, we would multiply both sides of this equation by -7, and that would leave us with -7 is equal to a. We can now substitute that into our formula, and we would get y is equal to -7 over x minus 3. And it's that simple, guys. That's how we would obtain the equation of the hyperbola using a given sketch. That's it for me. All the best, and I will see you in the next one.